আজ আমরা যে চ্যাপ্টারটা নিয়ে ডিসকাস করব সেটা হলো ইলেকট্রোম্যাগনেটিক ইন্ডাকশন। আজকে আমরা ইন্ডাকশন চ্যাপ্টারটাকে নিয়ে ডিসকাস করব। তো ইলেকট্রোম্যাগনেটিক ইন্ডাকশন কিন্তু আফটার ম্যাগনেটিজম ইন্ডাকশন আর এসি আমাদের কম্পারেটিভে কিন্তু একটা ইম্পর্ট্যান্ট রোল প্লে করে। ইন্ডাকশনটা বেসিক্যালি খুব একটা ফর্মুলা বেসড না, কিছুটা কিন্তু এখানে একটু কনসেপচুয়াল কিছু সাম আছে। তো সেই রিলেটেড আজকে আমরা কিছু সাম ডিসকাস করব। তো ইন্ডাকশনে মেনলি যে লটার ওপর ইন্ডাকশনটা বেসড আছে সেটা হলো ফ্যারাডে ল অ্যান্ড লেন্স ল। যে নাও হোয়াট ইজ ইলেকট্রোম্যাগনেটিক ইন্ডাকশন, যদি আমরা হোয়াট ইজ ইলেকট্রোম্যাগনেটিক ইন্ডাকশন এই নিয়ে ডিসকাশনে যাই। সাপোজ একটা ম্যাগনেট আর একটা কারেন্ট ক্যারিং লোক। If there is a relative motion between the magnet and the current carrying loop, যদি suppose দুটোর মধ্যে কোনো relative motion থাকে, means suppose magnetটা fixed, the loop is in motion, or loopটা fixed আছে, magnetটা motion-এ আছে, then an EMF plus a current is generated inside the current carrying loop, and that phenomena is known as electromagnetic induction. Why electromagnetic? Because in that case magnetic energy is converted to electrical energy, that's why electromagnetic. And why induction? Because এখানে লুপ আর ম্যাগনেট এই দুটো কিন্তু ইচ আদারকে টাচ করছে না, দ্যাটস ওয়াই দ্যাট ইজ ইন্ডাকশন। এবারে ইলেকট্রোম্যাগনেটিক ইন্ডাকশন ফুললি বেসড অন ফ্যারাডেজ ল অ্যান্ড লেন্স ল। যে ফ্যারাডেজ ল যেটা এক্সপ্লেন করবে হোয়াট ইজ দ্য কজ অফ ইলেকট্রোম্যাগনেটিক ইন্ডাকশন অ্যান্ড হোয়াট ইজ দ্য ভ্যালু অফ ইন্ডিউসড ইএমএফ। And according to Faraday's law, induced EMF is directly proportional to rate of change in electric flux, rate of change in magnetic flux, sorry. And according to Lenz law indicates the direction of induced EMF in the circuit. And according to Lenz law, direction of induced EMF in the circuit is such that it opposes the cause due to which EMF is induced. যেটার জন্য EMF induced হচ্ছে ও সেই কজটাকেই কিন্তু অপোজ করবে। দ্যাটস ওয়াই ইলেকট্রোম্যাগনেটিক ইন্ডাকশনে নেট ইএমএফ যেটা প্রডিউস হচ্ছে, ইএমএফ ইকুয়ালস টু মাইনাস অফ ডি ফাই ডিটি, ওয়ার ডি ফাই ইজ চেঞ্জ ইন ম্যাগনেটিক ফ্লাক্স অ্যান্ড ডিটি মিনস চেঞ্জ ইন টাইম। তো আজকে মোটামুটি এই ফর্মুলার ওপর বেস করেই কিন্তু আমরা যে নিউমেরিক্যালসগুলো আছে, যে প্রবলেমসগুলো আছে, সেই প্রবলেমসগুলোকে নিয়ে একটু ডিসকাস করব। তো আমাদের যেটা ফার্স্ট প্রবলেম যেটা আমরা চুজ করেছি, two conducting rails are placed perpendicular to each other. Here suppose AB is a conducting rail, BC is another conducting rail. They are placed perpendicular to each other such that their ends are joined. A conducting bar is now placed over the rails and start moving with constant velocity v. This rail PQ is moving with constant velocity v from the vertex at time t equals to 0. That means initially, suppose the position of the bar is here, এখানে ছিল, when t equals to 0. We have to find out the flux through the triangle by the rail and the bar at time t, and also we have to find out the EMF around the triangle at that time. So here at time t, total displacement that equals to Vt. So this angle is 45 degree, this angle is also 45 degree. This is isosceles triangle, a type of isosceles triangle. Therefore this is also Vt, this is also Vt. So in time t, area covered that equals to half into base into height. So here the base of the triangle, that is 2Vt, and height equals to Vt. That means V square into T square. This is area covered by the triangle. Now we know that flux phi equals to B into area. means magnetic field into area. So that is B into V square into T square. This is the flux through the triangle by the rails and the bar at time t. Now we have to find out EMF induced. So induced EMF E equals to mod of minus d phi dt. So after differentiation, so after time t, EMF induced E equals to B into V square into 2t, that is 2b V square into t. This is the EMF around the triangle at that time. Now my next question is, a uniform magnetic field exists in a circular region of radius r centered at O. The field is perpendicular to the plane of the paper and its strength varies with time as B equals to B0 into T. We have to find out the induced electric field at a distance r from the center for r less than capital R and r greater than capital R. Now consider, here is the region centered at O. Here is the region centered at O and radius is capital R. Here B equals to B0 into T. Now we know that surface integration of or close integration of or path integration of E dot dl, that equals to minus d phi dt. So path integration or close integration of E dot dl, that equals to minus d phi dt. First we have to find out magnetic field when small r is less than capital R. So integration of E dot dl equals to minus d phi dt. Here the value of E dot dl, that equals to E into 2 pi r, because dl means integration of dl means total circumference of the loop. We have to find out or consider this is the ring having radius small r. So phi equals to b into a, that means b0 into t into pi into small r square. So E into 2 pi r, that equals to minus of d dt of b0 into t into pi r square. So after calculation, we get the value of E as minus b0 by 2 into small r. So from this calculation, we can conclude that here electric field is directly proportional to r. Here electric field is directly proportional to small r, and this is electric field when r is less than r. Now we have to find out the electric field when r is greater than capital R. Now this is the region capital R centered at O. So when r is greater than capital R, then phi equals to b into a, that means b naught into t into pi into capital R square. So from this formula, integration of E dot dl, that equals to minus d phi dt, we get E into 2 pi r, that equals to minus d dt of b0 into t into pi r square. That means E equals to minus b0 into capital R square by small r. So from this equation, we can conclude that here E is inversely proportional to R. So inside the circular region, E is directly proportional to R, and outside the circular region, E is inversely proportional to R. Now my next question is self-inductance of 80 microhenry of a uniformly wound solenoid having resistance 3 ohm is broken up into two identical coils. Those coils are connected in series across 6-volt battery of negligible resistance. Find time constant and steady state current. Now what is inductor? Inductor মানে যেখানে ম্যাগনেটিক ফ্লাক্স ইনডিউসড হচ্ছে সেটা হলো ইন্ডাক্টর. Now there are two types of inductance. One is self inductance and another is mutual inductance. এখানে self inductance এর কথা বলেছে. Self inductance is denoted by small l and that is 80 microhenry. That is 80 into 10 to the power minus 6 Henry. Here resistance of the coil, that is 3 ohm. Now self inductance of a solenoid, that is mu naught into n square into pi r square divided by L, where mu naught is permeability of free space, n means number of turns in the solenoid, and small r means radius of the solenoid, and small l means length of the solenoid. So here the self inductor or the inductor coil is broken up into two identical coils. If it's broken up into two identical coils, then n dash, that equals to mu naught into n by 2 whole square into pi r square divided by L by 2, and that equals to capital L by 2. That means the coefficient of self induction reduced to half. Now we know that resistance R equals to rho into L by A. That means rho into 2 pi R into N divided by A. If we take, there are n number of turns. Now when it broken up into two identical coils, then n dash become n by 2 and L become L by 2. So R dash becomes rho into 2 pi R into n by 2 by A, that equals to R by 2. That means resistance also become half. Now these two inductors are connected in series. Here is L by 2, resistance is R by 2, and here is a battery of 6 volt. So here equivalent inductance, that equals to L by 2 plus L by 2, that means L. Equivalent resistance, that equals to R by 2 plus R by 2, that equals to R. Now time constant tau equals to L by R. Now put the value of L as 80 into 10 to the power minus 6 and put the value of R as 3. The value of R is 3. This is the value of time constant, and current flowing through the coil, that equals to E by R at the steady state. So that is 6 by 3, that is 2 ampere. My next question is, in a uniform magnetic field, a metal frame is located perpendicular to the plane of the conductor and varying with time at the rate of 0.2 Tesla per second. Here is a metal frame. Now a conducting connector starts moving with an acceleration of 30 centimeter per second square along the parallel bars of the frame. The length of the connector equals to 44 centimeter. We have to find out the EMF induced in the loop at t equals to 1 second after the beginning of the motion. Now this is the metal frame. Consider at t equals to 0 second. Here is the connector, and when t equals to when the time is t, then let the displacement of the connector that equals to x. And here the acceleration is given, that is 0.3 meter per second square. So we know that x equals to half at square. Consider the connector initially is at rest. So x equals to half at square. So phi equals to, here the value of phi, that equals to b into a, that means b into l into x, where l is length of the connector, that is 0.44 meter. Now EMF induced, that equals to mod of minus d phi dt, that equals to d dt of b into l into half a t square. Here the value of v, b এর ভ্যালুটাও কিন্তু উইথ রেসপেক্ট টু টাইম ভ্যারি করছে, তো b আর t দুটোই কিন্তু এখানে ভ্যারিয়েবল. So here the constant is L into A by 2. After differentiation, the value is like that, t square into dB dt plus b into 2t. Here the value of dB dt is given, that is zero point 0.2 Tesla per second. Value of L is 0.44 meter. Value of A is 0.3 centimeter per second square. Time is also given, that is 1 second. But b এর ভ্যালুটা কিন্তু given না, তো b এর ভ্যালুটা আমাকে ক্যালকুলেট করতে হবে. Here value of dB dt, that is 0.2. So b equals to integration of dB, that means 0.2 into integration of dt, 0 to 1, and that equals to 0.2 Tesla. Now here put the value of L as 0.44, value of A as 0.3 by 2, value of t as 1 square, value of dB dt is 0.2, value of b is also 0.2 into 2 into 1. Now find out the value of E here, which is in volt.